In this video, I want to show you how we can use loops to iterate through data rather than just count. So in this particular video, I want to show how we can use loops to iterate through lists. And if you're not sure what iterate means, it just means go through some kind of data one element at a time. So for example, if I've got this grades list here, let's suppose these are your grades in a course, and I wanted to print each one way I could do this would be with a for loop. And I could say for like I in range, and I'm using the letter I here just because I think it represents, I'm going to use it to be an index of an element in the list. So if I said for I in range, len grades, there are 12 grades in the list, so this range will go from 0 to 11. And just the way, when you do a range, you can do two numbers, and it's always the start and the up to but not including end. But if you leave the first number off, then it assumes it's 0. All right, so, and if I wanted to print everything, I'll say grades I. So when we run this, over here so we can see the output. Right, you can see that we printed all the grades in order. So on the first iteration of the loop, I was 0, so it printed grade 0. And then on the next iteration, I turned into 1, and it printed grade 1, and then grade 2, and so on, all the way until it finally got to grade 11 at the end. Right, length is 12, so it goes up to but not including 12, which means we stop at 11, which is what we have. All right, just to neaten this up a little bit, I'm going to do the trick where we do the end equals, and so now on future runs, things will go sideways, so I can see more output at once. All right, so this is nice, but it's a little bit of a clunky. Python has a shorthand that's a little bit simpler than this for iterating through a list. So another way we can do this is just, let me put a blank print here first, is I can say for, and I just make up a variable. So my list is called grades. So I'll just say G seems like a nice variable name for an individual grade in the grades list. And I say G in grades. And I can say print B. And this does the exact same, the exact same thing. Okay, so now this is a simpler way of iterating through a list, and what happens here is, this is an iterable type of data structure because there's many elements in it, and so G is just a temporary variable that takes turns being each element in grades one at a time. So on the first iteration of the loop, G is set to 72, so we print it. On the next iteration of the loop, G is set to 100, and we print it, and then 92, and so on. And we don't have to worry about what's the length of it, and we don't have to worry about this somewhat messy notation with the brackets and the subscripts and the index and all that kind of stuff, right? If we just wanted to look at everything one at a time in order, we eliminate the need for that index variable as well. All right, so now we know a simple way to iterate or loop through a list. But let's solve some actual problems with this. So the first one we'll look at is, how do we find the sum? And I'm going to go through 3 algorithms here, and these are algorithms that you should have down pat to where you basically memorize how to write the algorithm, and these are basic things that any competent programmer can do without thinking. So what is the sum of all the grades? So what we have to do first is we're going to declare an initializer variable. So I want to find the sum, and one of the things I notice when I'm coding Python is sum turns a different color. It's like, oh, that's a built-in function, so I don't ever use sum as a variable name. I'm going to use total instead, and I set total to 0. And then I'm going to loop through all the grades. So I'll say for G in grades, and I'll say total plus equals G. And then I can, so what's going to happen here is the total gets set to 0, And on the first iteration of the loop, the 72 gets added into the total. And then on the next iteration of the loop, the 100 gets added into the total, and then the 92, and so on, until we've added every single grade into the total. So by the time we finish, they're all together. So I can print total. And let's see if it works. There we go. So we know that the total of all these grades is 950. We can look at things conditionally. So there's another algorithm, which is a counting algorithm, and it's very similar to a summation algorithm, where I'm going to declare an initializer, and I'm going to make my initializer, like descriptive of what I'm counting. So total is good because I'm finding a sum. I'm counting the number of B's. Actually, it's not the number of B's. That's the number of A's and B's that we're counting. And so we'll loop through it again for G in grades. And so I'm going to say if B, and if it's a B or better, right, we're looking for grades that are at least 80, right? We're just using our standard grading scale. And so now I'm doing something conditionally in my loop. And I'm going to say the number of A's and B's plus equals 1. So each time we see a grade, so this time we're looping through the grades one at a time. And each time I see a number above 80, I'll increase my count by 1. And then I can print. And let's see if it works. And so we've got 7. And let's see, there's 1, 2, 3, 4, 5, 6, 7. So it looks like our code is correct. Right. And the third algorithm that we all should know is it's a max-min algorithm. So in this case, I'm going to find the max. I'm going to do a max algorithm. And if you think about it, the min algorithm is going to be very similar. So I'll leave that up to you to figure out the problem later. So what's the highest grade in the list? Now, computers think differently than humans when they're looking at that. Like I can kind of look at that whole list and kind of scan it and see a bunch of grades at once and go, oh, okay, there's the 100. I see that. That's the highest grade. It's the same with like, finding the tallest person in the room. I could, if I look at a whole bunch of people, I could kind of look at a whole bunch at once and maybe pick out who's the tallest. But a computer can't do that. A computer can only compare 2 things at a time. So a computer can't look at this list kind of all at once and see, oh, there's the 100. So what we're going to have to do is I'm just going to go ahead and assume that the highest grade is the first element in the list. So that's going to be nums or grades 0. Now, it might not be the highest grade in the list. But what I'm going to do with this is I'm going to loop through the grades list, and I'll say for G in grades. And then I can say if G is greater than high, then the high is equal to G. So what's happening here, let's see if I can get this all on the screen at once. Let me tighten this. Okay, let me tighten this up so it all fits. All right, so what's happening in this is, high right here, we're actually not setting it to the highest grade. We're just setting it to any grade in the list to start off with. And then as we go through the list, right, so the high is 72, and then like the very first iteration of the loop, we actually look at that same value again, and is 72 greater than the high? No, so we don't do anything. Let me change the order of this a little bit. I'll move the 100 somewhere else. Okay, so you can see. So is 72 greater than the high? No, so we don't do anything. Then we look at the 92. And is the 92 greater than the high? Yes. So I take the 92 and I set the high to that, and the high is no longer worth 72. So we're just updating the high. Then I look at the 47, and is the 47 greater than 92? No, so we don't do anything. And I look at the 100, And is the 100 greater than the 92? Yes. So we update the high to be 100. And then, we look at the 50 and it's not bigger and nothing else is bigger. So the high remains 100 for the remainder of the loop. So, right, so what's happening in the loop is the high variable is just the highest we know of so far. And by the time we get to the end of the list, right, this algorithm guarantees that the high will have been set to the highest number in the list. And so we can print out the high, and hopefully we see 100. And we do. Okay. So right, again, the algorithm just, if you're looking for the max or the min, just set it to the first element in the list and then loop through the list and then just update it every time you see something that is, higher, or if you're doing a min algorithm, update it every time you see something that is lower, right? So these are 3 algorithms, again, that any proficient programmer, competent programmer, has these down cold, all right? These are not complicated things that you should have to think about. So take extra time to study these and make sure you really understand them, all right? Now these algorithms, maybe it makes sense with numbers, but the reason they're important is sometimes you have similar problems that don't necessarily involve numeric data, but these algorithms are still in there. So this time I have a list of terms. And by the way, when you have a long list like this, I do not like having to scroll sideways in my code. So it is okay to hit enter in a list as long as you don't do it between quotes. So I usually do it after a comma, and I just line up, the next line like this. So this won't break the code. This is valid syntax. All right, so here we go with another counting problem. It's how many terms have at least 6 letters. So, it's very similar to this, how many grades are B or better. So I'm going to make a variable. This is my accumulator variable, and I'll set it to 0. I'll call it 6-letter terms. And I'll say for T in terms, right? This variable you choose right here, it can be whatever you want. I always make my lists have plural names. And then if I'm iterating through them, since this is just a little temporary throwaway variable that exists during the loop, generally I just make it the first letter of the list, and that's good enough. Okay. But you can make it whatever you want. Like for term in terms would be fine as well. Okay. So I'm going to check the length, and I'm going to say if len t, right, this is the individual item in it, is greater than, it says at least, so it's greater than or equal to 6, we'll do 6-letter terms plus equals 1, and then we can print that value at the end. And so we get 6-letter terms. There's 1, 2, 3, 4, 5, 6. Okay. And I always, after you write your code, double check and make sure that you got the expected result. Okay. And here's another one. It's what's the longest term in the list. So this is a max algorithm again. It's very much like finding the highest grade, only now we're just going to say the longest term, and it's going to be, we have to set it equal to something. So terms 0 would be good. Okay, and I know that I can look at this and I can tell you that binary is not the longest term in the list. And even if I didn't see the list, I would figure, well, this is probably not actually the longest term, but let's just assume it is for now. And so we'll say for t in terms. And what I'm going to do is check if length of t is greater than the length of the longest, then we'll say longest equals t. And then we'll print longest. And so, this time, instead of updating a number every time, we're updating a term. And, the only difference really is we have to make the proper, a slightly different comparison. We're comparing lengths this time, not just straight up comparing values. Like, it wouldn't make sense to see if T is greater than longest, because words aren't compared numerically like that. So, right. And there we go. There's our longest term. So, all right. So now that you've seen this video, I have some similar problems for you to work on. And so, in each block, just write a loop that finds the, each of these blocks, you're going to have to do some kind of accumulator, and then you're going to have to write a loop that finds the indicated information, and then go ahead and print it out. And do me a favor when you do these problems, don't delete the comments. Just put your code right below the comment so it's easy to see the intent of your code. Right, these comments should stay. And if you have any questions, let me know.